This section looks at classifying polygons when we see them in the coordinate plane. And so we want to decide what they are, mostly based on the slope formula, the distance formula, and the midpoint formula. So these, again, are a review of the formulas that we have learned in Algebra 1. We want to use the distance formula when we want to find when sides are congruent or diagonals are congruent. We use the midpoint formula for looking for diagonals bisecting each other, or else sometimes if we want to find the midpoint of a side for things like midsegments. The slope formula is going to be used to decide if things are parallel or perpendicular. So this first question is looking at a triangle. We want to know if it is scalene, isosceles, or equilateral. Now all of these things talk about the lengths of the sides, which means we're going to be using the distance formula to find out how long those sides are. So we just start one side at a time, A to B. First we need to find the coordinates here. So if we look at A, we can see that that's at 0, 1, B is at 4, 4, and C is at 7, 0. We'll plug these into the distance formula. Starting with AB, we have 4 minus 0, and 4 for our y's, 4 minus 1. Simplifying that, we're going to get 4 minus 0 is 4, which is 16. And 4 minus 1 is 3, so plus 9. And that's going to give us the square root of 25 over 5. Next we'll look at BC. Again, using the distance formula, we'll take 7 minus 4 for the x's and 0 minus 4 for the y's. It's going to give me 3 squared again, which is 9. And negative 4 squared, which would be positive 16. And again, we're getting the square root of 25, which is 5. So we got two lengths of 5 here. So we're at least isosceles. Let's check for equilateral. And so we're looking at the third side, AC. Subtracting 7 minus 0 and 0 minus 1 is going to give us the square root. 7 squared is 49 plus 1, the square root of 50. I don't need to simplify this. This is enough to see that it is different than the other two. And so it's enough to say that we're dealing with an isosceles triangle. This page is a list of all the tests we can use to find out if something is a parallelogram, a rectangle, a rhombus, or a square. I'm not going to read them, but we would use the midpoint, distance, and slope formulas to find out if we meet these tests. The only ones that we cannot meet on this page are the angles bisecting each other. But we can check things like if they bisect each other, then they have the same midpoint. If things are perpendicular, then they'll have slopes that are negative reciprocals of each other. We can also check lengths to make sure they're the same size by just using the distance formula. In this example, we want to see if this is a rhombus. Now first let's check to see if it's actually a parallelogram. The easiest test for that is to check if the diagonals bisect each other. Because if they bisect each other, we'll have the same midpoint. I only have to calculate two things. We're going to find the midpoint of BD and the midpoint of AC. We're checking to see if these two midpoints are the same, which gives us 1 and 5 over 2. For AC, we also get 1, 5 over 2, which confirms that the midpoints, these are bisecting each other at the same midpoint, and so this has to be a parallelogram. The next thing we want to check is if it's a rhombus. So the easiest test now that we know that it's a parallelogram is to check if we have a perpendicular here. To check for perpendicular, we're going to use our slope formula. We'll do that again for BD and for AC. So we get 3 over negative 2. For AC, giving us 5 over 6. At this point, we can see that these slopes are not negative reciprocals of each other. Because this one, if I flip it over, should have given me 2 over 3, and these are not equal to each other. So I know this is not a rhombus. So next we might think about what are the easiest tests, because there are a lot of ways we could check the parallelograms. And usually I found that if we want to check if it's a parallelogram, we should just check the midpoints, because then there's only two things we have to plug in. After we know it's a parallelogram, the easiest test for a rectangle is just to check if we have right angles on our sides here, so we can check that using slope. With a rhombus, if we already know that it's a parallelogram, we can check the midpoints of the diagonals. Okay, that's what we're doing with a parallelogram, and then check the slopes of the diagonals as we just did to see if they're perpendicular. With a square, we just check if we have a rectangle and if we have a rhombus, so we'd have to do all of that work to make sure it fits both of those. In this last example, we're given a kite here, and we're asked to classify the figure formed when we connect the midpoint. So if we're looking at the midpoints of each side on here, first we should look at the coordinates of points. These points are 0, -4, -4, 0, 0, 4, and 8, 0. It should actually be pretty easy to find the midpoint since these are all on right triangles here, and we're all on the axis. Since this is going from 0 up to 4, halfway would be 2, so the y values are 2. Halfway between 0 and 8 would be 4, so we're looking at 4, 2, and 4, -2. Over here we're looking at -2, -2, and at -2, 2. So if we connect the dots on this to see what figure is being formed by those, that would be that line, dot line, there. As we look at that, we should suspect that that's probably a rectangle, but maybe we should confirm that. And the best test to do that is to just check the slopes of those sides. As we look at this, if we did plug into our slope formula, we will get a slope of 0 right here for this first side. For this side over here, we're going to get an undefined slope because it's a vertical line. We can see that because our x's are not changing. Same thing on this side, our x's are not changing, so it's also undefined. And then on the bottom, our y's are not changing, so our slope is 0. So we should recognize that we are perpendicular when moving from 0 to undefined slope. Opposite sides are parallel, everything's perpendicular, so yes, this is a rectangle.